Okay, good morning, friends. Today we are going to discuss about Lewis dot structure of any compound or molecule. Before to learn that Lewis dot structure of compound and element, we should first learn that the term covalency. What is the covalency means? When an element shares electrons with other atoms of the same or different elements to acquire stable electronic configuration. It is called a covalency. So that is the definition of the covalency. So examples here. If an atom share one electron, its covalency is 1, and if it can share two electrons, its covalency is 2. So the covalency of an atom depends on, while forming a molecule, how many electrons, particularly valency electrons, it is sharing with other atoms or surrounding atoms. So here one note is there, that note, some elements can show different covalency because of presence of d orbitals in the atom. Example, sulfur, phosphorus can show variable valency because of what? In their atom they have a d subshell. So S is equal to, it can show the variable valencies 2, 4, 6, and phosphorus is 2, 3, 5. So okay, another important point is here, that is, the atom of any element always want to be at its maximum covalency for more stability. But here the maximum covalency is depending on the how many surrounding atoms are available and how many electrons they are sharing. If the electrons are plenty or maximum, the atom want to be at its maximum covalency state. So it is depending on the availability of the electrons. By example we can see. So now I am taking an example of molecule NO3 minus. And first we have to know that electronic configuration of nitrogen is 1s2, 2s2, 2p3, and oxygen electronic configuration is 1s2, 2s2, 2p4. So before to that we have to discuss some terms here, that is Q. Q is total number of valency electrons. Total number of valency electrons of each atom means nitrogen, and 3 oxygen atoms we have here. So Q is equal to, first nitrogen. We already seen nitrogen have how many valence electrons here? 5. So one nitrogen atom we have in the compound, that's why 5. And next oxygen has 6 valence electrons. How many oxygen atoms we have in our compound? 3 oxygen atoms we have, that's why 3 into 6. And here on the compound minus charge is there. Minus charge means we already know electrons are negatively charged particles. So one electron we have to add, additional electron we have to add, that's why here plus 1. Total is equal to 24. And next bond pair electrons. As nitrogen is central atom and oxygen is the surrounding atoms, first form a single bonds with nitrogens, each oxygen to the nitrogen. So bond pair electrons, remember each bond contains 2 electrons. So 3 bonds means 3 into 2, 6 electrons. Next, lone pair electrons. How we can calculate lone pair electrons means, here is a formula, Q minus bond pair electrons. We already know Q means total number of valency electrons. We already calculated, that is equal to 24 minus 6, that is equal to 18. So here 18 is the lone pair electrons. These 18 lone pair electrons can be used into 2 types. One is to complete the octet of the surrounding atoms. First preference is this is first preference. And if the after the completing of octet of the surrounding atoms, if still electrons are available, we use that electrons to use as a double bond or a triple bond. Okay friends, so this lone pair electrons can be used as to complete the octet of other electrons surrounding atoms, and if required, this lone pair electrons used as form the double bond or a triple bond. This is very very important. So now we are going through the one example, that is, as we already discussed, NO3 minus. So first form the molecule of NO3. Central atom is nitrogen and triple bonds I formed. So first, and we left it with the 18 lone pair electrons. First complete the octet configuration of surrounding atoms. Here the surrounding atoms are what? Oxygens. So in this oxygen, already in bond, how many electrons are there? 2 electrons are there. Remaining arranged like this. And here also, already in the bond 2 electrons are there. Remaining 6. 2 electrons are there. Remaining. Actually, this is not there, friend. Base series. So this is a mistake later. So it is not there. So here 6 electrons. So if you calculate this total electrons, here 6, here 6, here 6, 18 electrons we completed. 8 electrons we completed, and octet of each oxygen atom is also completed. But what about the, look at the central atom nitrogen. Here octet of nitrogen atom is not completed. So what we have to do here? So simple, as I already told to you, the lone pair electrons can also be used as to form, if electrons are deficient, the lone pair electrons can be used as to form a double bond or a triple bond. So I will show you the diagram in the next page. Okay, I can so here what we are going to do, we are able to going to do like that, to cancel a lone pair here, and take these electrons and form again another bond here. Here also 2 electrons are there. So now see that octet of each atom now completed. See, nitrogen point of view, 4 bonds. I already said 4 bonds means how many electrons? 8 electrons. Each bond contains 2 electrons. Here completed, octet of oxygen completed, octet of oxygen completed. Right. So if we observe carefully, this is the structure, but on the compound, what is that? Above the compound, 1 minus charge is there. So to which atom we have to give this negative sign? We will go through that. Here another important thing, that is called formal charge of each atom, Fc. So formula for formal charge Fc is equal to valence electrons minus lone pair electrons minus bond pair electrons by 2. So for example, for nitrogen point of view, formal charge is equal to we already know nitrogen has a valence electrons of 5 and lone pair electrons. As we already seen in that diagram, nitrogen do not have any lone pair electrons. That's why lone pair electrons are 0. And bond pair electrons. Bond pair. Here we see already nitrogen forms how many bonds? 1, 2, 3, 4. 4 bonds. So 4 divided by 2. That is equal to 5 minus 4. That is equal to minus 1. So nitrogen formal charge is minus 1. Sorry friend, I did a mistake here. Excuse me. 5 minus 4 means plus 1. By mistake it has happened.